Cool. All right. This is us.
Hello again.
So, what we're gonna say really quickly is that we're a production company. We have a staff of about almost 20 developers, engineers, designers, artists, animators, things like that. A really talented group of people. And what we're kind of seeing these days is this kind of trend where Hollywood is really starting to adopt a lot of the tools and techniques in creating entertainment content that video game developers and people that have been using real-time engines have been using for a very, very, very long time. So we want to talk really briefly about that in the time that we have. And that's what we're going to kind of cover today. This is a bit about us.
So who are we anyway? Our team consists of comes from very prominent entertainment companies in film, television, animation, and video games. These are some of the companies that our team has worked for. This is some of the properties that our team has done in the past. And we have prominent partners, Michael Bay, Linda Opes, who are phenomenal director, writer, artist, that are part of our company. So we're working with really high caliber Hollywood talent, artists, and doing these properties.
Yeah, so again, the point is really we're trying to bring this kind of convergence together in our studio. It's something I've been very passionate about for a very, very long time, ever since my time in feature film and also in video games and bringing them together. So finding people that really understand that, they can do really high-level imagery, such as, Michael Bay and Linda Opes, who are very well-known for very high-level, CG-type movies. They really understand the space pretty well. So what is real-time? What are we talking about? How many people here have actually had any experience with real-time engines? Things like these, Unreal, Unity, Crytek, a few people. There's many, many engines. These are the three prominent ones you can get. They're very readily accessible. We like them, we use them. Right now we've done a project in Unreal for virtual reality to kind of just get the, kick the tires and figure out what we can do in these engines with things that have really high expectations for production value, like virtual reality. But look, what these guys really want you to do is ultimately make a film out of their engine. It would make their day, right? And so for us, we're looking at how these engines can help us in the creation of art assets, animation, effects, as well as things like previs and cinematics. But of course, none of those engines are what they could be without really amazing hardware. AMD and NVIDIA, if you guys are familiar, they're graphics processors. AMD does CPUs as well. So pretty much the hardware that powers these experiences and these engines are very, very vital. And really, at the end of the day, it's combining these two things together with a proper kind of art authoring and design that really make things shine, right? So these tools are great, and together we bring them, and this is how we make things. But at the end of the day, we do have our challenges. These engines, it's harder, they have their limitations. So we're going to chat really quickly about how we kind of circumvent a couple of those things in the time we have. We're talking about frame rate. It's very important, especially in dealing with virtual reality or multiplayer games. We're trying to keep a virtual camera from keeping its frame rate up and running so that we can actually create content that runs smoothly, that doesn't have any latency, whether you're playing against other people or whether you're in VR and you need to actually see things and not get nauseated. It also is very important when we're doing things, working with directors and people like that they see things in real time very quickly. Part of what makes real time awesome is the fact that you can iterate very quickly. So that is also very, very important. In other words, you can set up a shot, you can move things around, look at the shot again, and do it almost instantly. Move things around, look at it, relight it, move it around, and we love that.
Also why it's vital that it runs at 90 to 120 frames per second.
So here's one technique we use, for instance. So we built this giant robot for this project called Crow that we released just recently. So it's a giant robot. This is first made in a very high-res model, the typical kinds of things you'd see watching a feature film, thousands and thousands and thousands of polygons, tens of thousands. And what we do is then we carve it down into very basic shapes. I think this is something that artists, if you're working in 3D, should really try to understand how to get things into a very basic shape. This here is what allows us once we add the proper textures and having a basic shape to back up those textures, understanding how they complement each other in creating content that actually looks much, much more high-res and more beautiful than the actual geo underneath it actually is, that mesh. So then when you add your shaders and you add your textures, you get something that looks pretty close to animation ready. But this is actually very, very, very easy on the GPU to render quickly. So this is one process we use throughout all of our content to get things to render in real time quickly and as I say, to move things through the pipeline. This is our robot finished. Again, this is animation ready, video game ready, virtual reality ready. Very light on the GPU.
And this technique can also be used in cartoony characters such as this fairy or in animation. If you take a look at the next slide, if you look at the details of the shaders and texture, especially in the eye, you can really see a difference. So that leaves us with a character that is ready for VR, for animation, and it also runs at 90 frames per second. And another way to use this technique, we can use this technique in different types of art. Another example is this giant dragon, or this drone, which is 36,000 polygons, and even in environments.
So again, using the same techniques, whether you're making props or you're making giant dragons or giant robots, the techniques still kind of really help in creating this kind of authoring kind of pipeline, if you will, to create things really quickly in an engine or alongside an engine. So all of this has a lot of value and coupled with a pipeline. So we have a pipeline, any studio does. And these pipelines are really important. In our case, what we have is a way to actually create, basically imagine a Lego box of pieces, and you want to kit bash it. So you keep building these Legos. All the Legos are already made. They're already, for a lot of the big pieces that we know will animate, they already have UVs and they've been rigged so that artists and animators can actually build things, look at it, put it through this pipeline into a real-time engine, take a look at it, light it. If they don't like it, they can take something out, put something back in, move things around. So you can imagine something like a soldier. He has a different helmet. You can switch the helmet very quickly. You can switch his gear, his gun, his backpack, his boots, whatever. And then figure out what looks best, how to compose the shot, and then move on, like light it and keep going. So there's that. There's the idea that automating the rig is really important, the skeleton that actually is underneath the art that you see. And for us, it's another very important thing that you can put into real time. So you take art, and our rig is it's very calm. It's a base rig, so the animators can not have to fool with that too much. They just have something they can make, they can put it in, the pipeline spits out something that animates very easily for them. So these things are really important. We can do this with guns, with characters, we can do it with giant dragons, we can do it with vehicles. So why is this all so important? Why are we talking about this? At the end of the day, when I mentioned that we're doing high-res assets like a giant robot or a giant dragon, we actually can use that same asset that's film ready and bring it down to different qualities like I showed. So we can use that same asset in virtual reality, in traditional games, in animation or film, and even to mobile with a few tweaks. So again, that's just about authoring from the onset. So thinking about what you think you're gonna have this thing look like down the line and authoring it up front to be able to work in those different facets and those different channels. Another thing that's really important for us is creating that previs in real time. So by doing step one and creating things that work well in different situations that perform well in real time, we can put them in a previs, and previs basically being the idea of looking at a scene and a shot in a rough format, putting it all together, and then arranging things like I mentioned. So very, very important. And third, points 1 and 2 really make up the third, which is time is money. So cutting down production costs are really important to directors, really important to filmmakers, video game developers, so forth, animation houses. So by using this engine, using these techniques, we think we can really help with just making things done quicker and cheaper and iterating faster, so things actually are better. They actually look better, and they're performant. So these are all things that really, I think, really are important with real-time engines and the kind of things that we think are the future of where a lot of these things is going. These engines are, like I said, they're being upgraded every day. They're being enhanced and added features all the time. So it's not going to be long before we see really higher and higher and higher quality things come out of these real-time engines.
And this is where we're really seeing the convergence of Hollywood and technology, with Pete's 11 years experience in film and animation industry, then on to the video game industry with over 11 years experience in Call of Duty franchise in the Modern Warfare, and I come from traditional television and film and feature animation as well as live action. We're able to work with the talent and develop this technology, and really you see where these stories and the technology can help produce and these films and really cut down on the pipeline, the production cost, and the whole productions that we have.
Yeah, we'll show you a really quick excerpt of a trailer we did to kind of show you what we're talking about in motion. That's all captured in VR, dynamic water, all that kind of stuff. So if we can do something in a very, very demanding kind of channel like that, then we can certainly do something in every other static and 2D version of content and entertainment. So yeah, thank you.
Anyone have any questions for us?
So we should be getting a couple questions up on the screen.
Will you consider storytelling in your presentation? That's a good question. This is tech open air, so as much as we love storytelling, we want to keep it more on the technical side and kind of get into that kind of avenue. But storytelling is really important with all this kind of stuff. I think iterating on the story is very easy to do when you can move things around very quickly. You can change scenes, you can change what's going on. I know in directing Crow, we had a lot of different pieces that got put in right away, right? So for instance, we have puzzles and combat, and moving things around were sometimes key to keeping the story flowing and having this character, which you showed earlier, the fairy character, actually tell you what to do and kind of guide you through this experience. And by manipulating her and her animations in real time, you can kind of move her backwards and forwards in the story, in the timeline, and then create moments where there's combat and puzzles and other obstacles for the player to go through while you're interacting with her. So there's a bit of a break, and then the beats kind of hit themselves a little better. So I would say really quickly to that question, you can manipulate beats in a story easier and see them in real time and see if they work or not by using an engine, by doing things.
Yeah, and we are story building and world building, so especially with every property that we look at and IP we look at, we definitely want to focus on the story and the character, because that's what actually makes the game, because you want to care about what's happening inside.
So another question from the audience. What do you think about other video game cinematics like seen in Uncharted, Last of Us, and Until Dawn? What do you think?
I mean, they're great. I mean, you can't knock. Naughty Dog is the king of cinematic video, especially. So, I mean, I don't know what to say. I love them. They're great. They're great games, and they're very engaging, very cinematic.
Another question. Are you working with volumetric VR as well?
We're exploring volumetric VR. Yeah. So there's pros and cons of volumetric VR, right? So you get a bit of the canned performance that you have to play the camera to. Again, so in real time, you can move these performances around closer and farther from the camera. You can adjust where the player is or where the audience will be, and hopefully you can kind of get a read from that. But those kind of things to be very careful with, because there's a lot of free roaming space in a VR. We're talking about VR right now. So if you move around too much, you might break that performance, right? Because they're going to be performing someplace else than you are. And so we're looking at it, but it's got to be used in different, at least in my opinion, in different places where it really can be cheated, so that you can get the shot right and not break the illusion.
And has any of you worked on Deus Ex?
Yeah. Our design director he worked on the original one. He was the assistant art director.
Somebody thinks it's the best game ever.
It is an amazing game.
I'm sure there's more than one person. And then last question, how are drones changing the filmmaking and how people consume content?
Those are two very different questions, I believe.
Yes, let's just do the first one.
But drones are interesting where you're allowed to use them. So when we film, there's VR drones, and of course there's regular traditional drones. And you can take those sometimes where you can't take a crane, which is very interesting, right, or a camera. So they are making things cheaper. We have not shot with a drone, but we've been on sets with drones, of course. They're interesting. They definitely can mitigate some production costs and get you a shot that you don't normally get, especially in things that we do in a game engine, such as I'll use Call of Duty as a reference, because we get a lot of shots that are overhead POVs as we set up the next level, and satellite shots and cool shots that would have been in a drone if it was shot in reality. And so those shots you can actually do now in film, and they're very maneuverable, and they're very quick, and they can add a dynamic kind of feel to a scene and get you into a spot where you can set up a location. So I think they're cool, and I think they do make things a little cheaper in some cases.
Very cool. Well, we're out of time. Thank you very much, Cathy. Thank you, Pete.
Yeah, thanks, everyone.
That was great.